All right, welcome everybody. Welcome to this week's NADOG online event. I hope everyone has their drink and is ready for an interactive web event here. If you have questions, comments, anything like that, we're just in a meeting room here together, so you can take yourselves off of mute, put yourselves on video. We want it to feel like we're all in the same room as much as possible. Speaking of same rooms together, starting on the 19th of January, we are going to be doing live events again. Starting in Irvine and then San Diego and then all over the rest of the country. So we'll get that schedule posted for everybody here by next week at the latest. For those of you I don't know, I'm Jim Schultz. I'm the leader and organizer of North American DevOps Group. Today's the 2nd of December, 2021. We're going to start this off as we always do with two quick lightning talks from our sponsors. And then we're going to introduce our speaker, who this week is Craeg Strong, CTO at Ariel Partners. He's going to talk to us about, he gave me another really long title. I keep getting long titles from everybody. Going serverless and agile transformation during a pandemic. So it should be a lot for all of us to talk about for this one. Then we'll wrap up with some Q&A after that. So if you have questions, though, don't feel like you have to wait until then. Drop them into the chat, or we'll try to pause a few times. Craig, if you don't mind doing that, just pause, see if anybody wants to come off mute to ask questions. We'll keep this very conversational if we can. And then after the Q&A and the talk, we're going to leave the line open for another 30 minutes if anybody wants to stick around and do some virtual socializing with us as well. As soon as I'm done talking, I'm going to drop 3 links into the chat. One to subscribe to us on YouTube, one to join us on Slack, and the other one is for next week's event, which is going to be delivered by someone from Bose. She's going to be talking about why every dev team needs a historian. So let me drop those into the chat. And our first lightning talk here today is going to be from our sponsor, New Relic. And Nashnika is going to deliver that talk, but Nashnika sent me a recording of the talk. So let me share that with everybody. And I'm going to play this first, and then we'll introduce our next lightning talk.
Hello, NADOG conference. Thank you so much for having me for this quick lightning talk. My name is Noshnika. You can find me on Twitter at serverless_mom. I work with serverless, obviously, and containerized workloads at New Relic, and I'm going to do a quick screen sharing demo of New Relic to go through how it works. I'm also available in the chat, so feel free to send me questions there. Okay, let's go ahead and get started. Let's look at a Lambda function being monitored by New Relic. So when we start out, we see information that kind of resembles just like a CloudWatch dashboard, and it's an easy enough question when you're trying to do observability for Lambda functions or serverless functions that it's reasonable enough to say, hey, well, how am I going beyond CloudWatch? How am I not getting just what CloudWatch has? So while things like duration and the number of invocations are all things you can get from CloudWatch, we already see that we're going a little bit deeper here into the information that's available. We see that instead of just seeing a duration time, we're seeing 2 separate pieces. We're seeing how long DynamoDB.putItem is taking and how much web time is taking. If we click into invocations, we can go down. We actually have data on every single invocation that comes through, along with the attributes and which components are taking so long. And you can see one of these patterns here, which is, hey, it's actually this DynamoDB component that's taking up most of the time of our requests. And things like these attributes that are available on the request. So you may have something here from your stack, including things like, customer ID or organization ID to help you drill in a little bit. But if we take a look at distributed tracing, we start to see where the differentiation really happens. And this is something you should consider anytime you're trying to do monitoring of a serverless function, is you want to try to get some kind of actual code insight. So here we're able to see individual methods that are happening inside this request. In this case, the Lambda function is mainly concerned with doing this DynamoDB put item. We're also seeing some other methods that are happening from a Ruby application. We're seeing some Ruby methods here. That's because we have another application running in an EC2 instance that is also, let me zoom in a little bit, that is that is also monitored by New Relic and is passing requests into our Lambda function. And we have this beautiful map here that shows us within this trace what were the other functions we were hitting, along with a detail view that says, hey, here's what's going on that entity. So these are the kind of things that we would really expect to be able to see if we want to monitor serverless successfully. So obviously a big piece with serverless is understanding that map. And this is a nicely zoomed in map. This isn't a complete service map, which we can also help generate, but this is letting us see, hey, when you had this request, here are where these other calls were going. And we can bop into the same view and look at logs as well for this request, and actually get logs right in with this performance information for this request. So that's the idea with monitoring serverless with New Relic, is we want to be able to get that kind of really zoomed in view to let you get a sense of what's going on within the individual code, and then also that kind of map view to let us see what are our connected entities and what does this represent within the full stack. At level side, we've got views like the lookout view here, which gives us a sense across our whole stack of the largest entities in terms of throughput, error rate, what have you, and also a sense of how they're trending. So a lot of this stuff is stable, but we're seeing that some of our services have a suddenly increased error rate. We see decreased error rate here as well. You can also get other kinds of high-level views like taking a look at data gaps, which actually suggests, hey, maybe we're monitoring some of your servers or on some of your services, but we see some other stuff, some other traffic that's happening that we don't have any kind of monitoring on. And so it will suggest some other points to add that kind of monitoring. You can also do things like viewing by host and container as well. Obviously, this is a demo environment. Some of this stuff is going to be pretty dense. But that's kind of the high-level side that we want to add to being able to have code-level view. We also want to say, hey, how is our entire system looking from a very high level? Of course, there's custom dashboards and stuff, but that's a very necessary part once your stack gets complex, to be able to say, hey, here's the stuff that my work really cares about, that my job or my team finds so important. You can even do some of that stuff automatically, where you can say, hey, anything that's tagged like this within, for example, our AWS system, go ahead and add it to a particular dashboard or workload. Okay, that's been my time, folks. Thank you so much for giving me your attention. Go ahead and find me on Serverless-Mom. At Serverless-Mom on Twitter, go ahead and DM me the word spaghetti, and I will get you some New Relic swag. So that's my final offer. Thank you so much, everybody, and have a great conference.
Come off mute. Awesome. Thank you to New Relic there. If you do have questions for New Relic or for Nashnika, please drop them into the chat. I'll make sure that they get over to them as well. All right, next up are our friends at Trend Micro. Hello, Chris.
How you
Florida.
doing?
Great.
All the way. And now I want spaghetti for some reason. I don't know. And I really, really do. But anyways, not going to suck up too much time. Chris Fontaine, I think I've actually spoken to some of you folks before. I'm a senior solutions architect at Trend Micro. Been with the company forever, it seems. So kind of what I want to go through is that, serverless needs security too, and serverless, it really needs love too, because the serverless model is regarded as relatively more secure than other cloud models. For example, in the case of AWS Lambda, AWS takes care of the underlying infrastructure, right? The operating system, the application platform. This doesn't mean that securing the security or securing the serverless model falls solely under AWS. Lambda users are responsible for securing their code, the storage, the accessibility of sensitive data, and the IAM, the identity and access management in relation to the AWS Lambda service, and also within their functions. In short, the service model that the users choose to use dictate what they're responsible for. And you'd be surprised how many people don't. The serverless model also requires customers to understand their responsibility in maintaining proper IAM, critical data storage and accessibility, the code quality. Cloud ops, DevOps professionals need to be responsible in properly configuring elements such as IAM and really kind of critical data storage as you set up cloud services to make sure that you're deploying secure code. Because if you don't, somebody like me comes along and has fun with it. As you can see on the slide here, and I'm sure we've all been through this before, where the attacker, who's got a very bad hat on, injects a shell command on AWS Lambda function with high permission, downloads and unpacks AWS CLI tools, checks roles and policies, and then modifies function timeout from 2 minutes to 15 minutes. There's going to be a couple QR codes at the end. You'll be able to watch a video on this that somebody else did who's much more interesting than me because they used a computerized voice. But as I said, just because it's in serverless doesn't mean it doesn't need to be secured. And I'll give you a few reasons why. It's all too easy to leave a bucket open, right? Or publicly accessible. It might not even be in the hands of dev. Most of the time that's like cloud ops and somebody screws something up and now you're on the hook for it. Creating bad or exposed code. We all know nobody writes bad code intentionally, right? Or creating bad or vulnerable code. The other thing is leaving sensitive data exposed, and this does happen more often than not. What's funny is when you, if you go and scour the news feeds from the last, week or so, you'll actually see that Amazon itself, now not AWS, but Amazon retail, left a whole lot of sensitive data, just kind of, we'll call it laying on the digital floor. A lot of people save credentials as variables, holy hell, and using vulnerable libraries. One of my favorite ways to target a particular entity is to put some bad code online. You get to know a company, you get to know what they're doing, you get to know somebody inside, they tell you what they're working on. Oh, let me tell you about this awesome code I saw up on Git. And that repository is just full of holes. And that's one of the best way to pen test into serverless right there. And then file persistence, of course, is a nightmare from hell that everybody tries to avoid at all costs. So there's a couple QR codes, and I swear this is not going to blow up your phone or send me all your photos, or is it? Now, actually, the one on the left, as you're looking at it, will take you to a great write-up done by Trem Micro. It's documents.tremmicro.com, and it talks about all the good stuff. Actually, that's the one on the right, pardon me. The one on the left is actually a site designed around security for serverless architecture. If you'd like to know more, you can always find me through Jim. And real easy to find on the Trem Micro site. Just look for Chris Fontaine. I'm also on LinkedIn, YouTube, every social media platform known to man. Don't be shy. Reach out if you got any questions, and have fun listening to the rest. Thanks, Jim.
Thank you, Chris. Yeah, if you don't mind, drop your LinkedIn and your home address and
will do.
Social security, all that stuff in there.
A cell phone number at all. Yeah, it all goes in chat. Yeah, I'll throw it in chat.
Thank you, Chris, and thank you to Trend Micro as always. Trend Micro has been our biggest sponsor, and actually through all of the pandemic and everything, they've been huge supporters in keeping this community alive during all this. So we really appreciate you guys. All right, we are ready to jump into our featured talk. I am very excited to introduce Craeg Strong, all the way over in Australia. Early morning for him today. He's drinking coffee. He's the CTO at Ariel Partners, and he's going to talk to us today about going serverless and agile transformation during a pandemic. Again, if you have questions during the talk, feel free to drop them into the chat, or we'll give you some opportunity to take yourself off of mute to ask as well. So Craeg, I'm going to hand the reins over to you.
Excellent. And just confirm you can see my screen just fine?
Yep, perfect.
Excellent, excellent. All right, so I'll begin. So thanks so much for having me here. And I'll jump in. So this is a brief agenda, but I'm just going to dive right in. So first, just a quick word about me. My company is a consulting company. We're actually based in New York City, and normally I am in New York City. I'm just on a little hiatus into Sydney, Australia, and be back soon. But as you can see, we do work with federal agencies, Air Force, Social Security Administration, FBI, and then commercial companies in New York City, HBO, and then finally New York City municipal agencies. Very interesting mix of work. I am a certified ethical hacker, apropos of what we just heard from Chris. But normally I spend my time these days as a coach, trainer, that kind of stuff. And this was all about working with the Air Force. And it's the BES Directorate. So BES is Business and Enterprise Systems. It's a directorate, and basically what they do is move the money and sort of track the movement of material, with the E. So they're sort of tracking what's going on and what needs to go where, and making sure that supplies reach where they need to go, and that kind of stuff. And as you know, that's how wars are won. So pretty important stuff. As we were working with them, they were helping to stand up the Space Force. So that was pretty exciting. So it was our very first time ever working with the Air Force. I never thought I would be. I never thought a small business would even get a chance to work with the Air Force, but who knew? Turns out they're actually very small business friendly, and they're very forward thinking. So it's pretty cool stuff. So anyway, it's, as you can see, big, giant organization, about 2,000 personnel. And when we first started, they said, you're going to train Jira. You're going to train us in Jira, and you're going to physically go to Texas and Alabama and these different places. So, and then boom, the pandemic hit. And so, it turned to be 100%. So the mission is to train all 1,200 in the directorate ASAP. So they wanted to go to Jira, and they were in a real hurry to do so. They're moving from waterfall to Agile. So constraints, everybody working from home. Oh boy. and we're talking about, cameras inoperative or intentionally disabled. So basically you're training to an empty room, pretty much. All roles, all ranks. So we had a colonel once, we had a captain in, to different people. So I learned to say, yes, sir, all the time in the training. Widely disparate needs. You've got maintenance teams, development teams, non-software, HR stuff, just totally different. So how do you teach one class to all these different, kinds of needs? No background in Agile, a lot of them. Never had gone to a CSM class. Like, really? You want me to teach Jira? And you've never been to, anyway. No, and many didn't even have Jira. Can you imagine? So, but if you think about it, the logistics of getting Jira rolled out to all those people all over the place, even that is a titanic endeavor. And so it was happening, but it just, not everyone had it at the time. So, so in the meantime, they were borrowing Jira from another agency. Now, you can actually go online to DI2E. It's this really cool site. You just see the homepage. You're not allowed to do anything else, but it's literally the intelligence community has stood up an instance of Jira and some other tools, and they make that available to some other agencies. But so they did that for a while, but after a while, I forget who it was, NSA or some three-letter agency we're not supposed to name, said, you guys now need to get your own. So, and they wanted the training in one shot. Now, normally when you're training online like this in Zoom, you just do a couple of hours a day. And that's really helpful for people. But they said, no, we want to cram everything into one day. So basically we said, okay, fine, we'll do this. Mission Impossible, we can do this. So we did a 2-day intensive course, hourly Zoom fatigue breaks. So 50 minutes on to 10 minutes off. It works. Browser only, 0 install. So we're very, everyone's using their own equipment. So it had to only require a browser. That's it. Everyone gets their own instance of Jira, because if everyone's sharing the same one, then I click a button, then you're going to see something different, right? So they all had to have their own instance. And we wanted this way more hands-on, right? If we're doing it's intensive, everyone's got to be hands-on all the time. That's the only way they're going to retain this stuff. And very realistic scenarios. In a lot of training programs, we've seen sort of contrived examples, little Mickey Mouse things. That wasn't going to cut it. We needed to have realistic scenarios that showed projects with Air Force names or Air Force-like names, something that really looked realistic. So they could, otherwise what happens is people say, oh, that training was wonderful. Too bad it has nothing to do with me. And I've seen that over and over again. Have you ever gone to a certified Scrum developer course and they do ping pong pairing and pair programming and stuff? Unfortunately, I hear a lot of people after those courses saying, that's wonderful. I wish I could do it. I only wish I could do that. And we couldn't afford that. We needed to have stuff where people could say, yep, I can do this. I see myself here. So, and the elephants in the room, dependencies, forecasting, documentation. They weren't just building software. They had to do a lot of documentation too. So, and program initiation. How do I even get started? How do I do customer discovery? So in other words, it wasn't just about teaching them Jira. It was about teaching them how to use Jira to get their job done. So it was like, how does Jira help me manage dependencies? How does Jira help me with forecasting? So, it's very much a Agile plus Jira kind of thing. So anyway, so we needed to bring some friends. For this, we needed help. So basically Kahoot, Miro, Google Slides, that kind of stuff. What we configured for training real quick, we configured a bunch of different tools, because one of the things about Jira, now this is not a advertisement for Jira, but one of the great things about Jira is it's very, very customizable. And a lot of companies don't really take advantage of that, which is highly ironic because that's like the whole point. So we configured a Scrum team. We configured a Kanban team, pure complete Kanban. We configured a Scrumban team, a little bit of Scrum, a little bit of Kanban. These are all very common scenarios, and they were all needed. And we configured a scaled. So show how Jira can support multiple teams all working on one giant project. And every single one of these was absolutely needed in the Air Force environment, and probably even more. But that's what we configured. So you can see each one of them. What I did, actually, I cheated. I went to the Air Force site, and they make a lot of information publicly available, including the list of their major projects. Now, I would have thought that was private, but nope, publicly available. You can see all the names. So we actually put those names in there. So they had the real names of the real software projects. We used a whole bunch of plugins, and that's one of the things about Jira is it has a huge third-party plugin marketplace, and that changes the whole game. Jira by itself, I won't say anything, but with plugins, there are some amazing plugins out there. Now, I know the process for getting plugins improved, and some of them are expensive. I get it, but basically, almost nobody should be using Jira without at least one or two good plugins, and these are the ones that we had configured. So here's what we configured at first. Here's how we got the job done. We basically configured GitHub Actions, and we created a Docker file with Jira. Jira configured. Actually, we got the official Docker image from Docker Hub for Jira, and we put our data in there. And Bob's your uncle. There you go. You got it. So basically, we used Anchor to scan the Docker image for vulnerabilities. I can't forget that. Did a little smoke test, published it into Docker, and there you go. So now we've got in the ECS container registry, it was called the Jira Fundamentals Docker image. And then at runtime, we actually just used the AWS CLI that Chris had alluded to. And we literally just cloned a whole bunch of instances. And there you go. Every single student has their own Jira instance, running under Postgres. It was just easy for us. We could have used a different database, but we used Postgres. And it worked. It worked. However, all was not perfect. So what were the drawbacks? Well, it was costly. It was labor intensive. So you had to have an operations person to start and stop all the instances with a script. And if you forgot to stop them, the AWS bill that you received the next month reminded you. So leaving these instances up was can get quite costly, right? So and you had to have all the CLI tools installed. So full computer required, no mobile, and you have to kind of be an expert. You weren't just going to hand this off to somebody and say, "Oh, can you just start these instances for us?" That ain't going to work. Provisioning in class is very slow. It could take up to 3 hours to spin up. And we weren't quite sure why that happened. It was something about the CLI and sort of, invoking things. There was some slowdown sometimes. A lot of times you're doing this the night before in the middle of the night. We weren't quite sure why, but it would often take a long time to spin up all these guys. And in one case, we were literally having a cliffhanger. We were watching the instances come online. And I was like, 10 minutes to class start, 5 minutes to class start, 2 minutes to class start. It was literally like a mission impossible. Oh my God, are we going to be ready to start the class? So that was hair raising. And you have to time the startup perfectly, because if you start them way ahead of time, then you're getting charged. And if you start them too late, the class isn't ready. So, and the extra instances required because some of the instances would crash. And that's because of how we configured them. We basically configured them as small as possible because, again, the larger instances cost money. So, but because they were kind of small, sometimes they would crash. And so we learned that you can't wait for new things to spin up. You got to have extras available. So manual coordination. So we had to match the students to the URLs. So we'd say, okay, you get this one, you get this one. And that was kind of a nightmare. The trainer couldn't see if the instances were healthy. Suddenly you get a, you'd say, is everyone okay? And then one person would say, my instance stopped working 15 minutes ago. Like, you didn't tell me, And so switching a student from a dead instance is kind of clumsy. It's sort of like, okay, you're using this URL, now use that one. So it's just, and the primary instance is always running because you're cloning from that. So, anyway, as you can see, there were a lot of reasons to change. So we looked around, we looked at different technologies, and we said, look at this serverless stuff. And what we realized is that serverless was like a perfect fit for what we needed. We needed to spin stuff up at a moment's notice and spin it down at a moment's notice. We had this independent stuff. I mean, if this wasn't tailor-made for serverless, I don't know what is. So we looked at it, we said, that's what we want to do. So here's the summary of what we changed. First of all, what we did not change. The AWS cloud infrastructure, the Elastic Container Service, the registry, the Docker images, using a S3 bucket, having CloudFront and API gateway, that didn't change, but everything else changed. So what did we change? Well, we had a whole bunch of stuff. We had Confluence and Jira and Jenkins, all this stuff to run our project. This is the preparation project and to do all the DevOps. And we just looked at GitHub and we're like, wait a minute, they have this new thing called GitHub Actions. That looks really simple. Let's try that. And it's a huge win. It's a huge win. Now, I'm not saying it will work for everyone because there are costs involved when you get to very lengthy builds and a lot of builds and stuff. But if you're if you're just doing a few builds, you don't have a giant team, it is a huge win. I love it. So it's all declarative, YAML-based build files. It's wonderful. And Bitbucket pipeline, same thing. GitLab, I think they're called build pipelines or whatever, something. But basically, that seems to be the trend, that people are moving away from imperative type style builds to declarative style builds, and from having to stand up your own CI/CD server to just having something there. So Jenkins, I think I've loved and hated you for 10 years, but I think your days are numbered. So Terraform is what we used before, and now we're moving to SAM. So why do we move to SAM? We'll get into that. This is just an overview, and we'll get into the details. So Beanstalk. Well, what are they? Terraform and SAM are declarative. They're scripting, so you can invoke infrastructure different scripts. So it's infrastructure as a service, that kind of stuff. Container orchestration. We were using Beanstalk. We moved to Lambdas with step functions and Fargate. So Node is kind of what we used at first, just this very simple JavaScript type thing. And now we move to Go in the back end, DynamoDB, Cognito, CloudWatch. And finally, last but not least, we had just started using a little bit of Preact and Amplify, and we decided we needed a full-on GUI with React and TypeScript and all that stuff. So I'm going to go into each one of these areas and explain why we made that switch and what benefits it gave us. But before I do, I realized that I should have stopped by now and see if there's any questions before I move on.
Yeah, feel free to unmute yourself if you'd like to ask a question, or you can type it into the chat. Just pause for a second if you want to come off of mute.
So I don't see anything, I'll keep going, but feel free to interrupt, just say, hey, got a question, or you can use the button that raises the hand. That works well too. Smoke signals. Probably won't see them over here in Sydney, but alrighty. So these are all the changes we made. So I want to go through them one by one and explain why and what the benefits were and sort of how it felt to do that. Well, first of all, why not Kubernetes? Everybody's talking about Kubernetes. Doesn't Kubernetes solve every possible problem you could ever have? And it's, I'm being silly, but really is worth asking that question because it's ubiquitous. Everybody's using it. Why did we not use it? Well, it's designed to run distributed systems resiliently. That's what it does. But this is not a distributed system. This is all in one. It's the opposite of a distributed system. So everything's in one Docker. It all automatically scales your app. We don't need scaling. This is all one instance. We don't want to scale it up. We're not doing it like that. It automatically restarts in case of failure. We don't need auto restart. It's a better user experience to switch to a hot standby because the start, it just takes too long to get started back up. We're live. We're in a live instructor-led training. It has a steep learning curve, which I have not yet climbed. I'll admit it. Part of the 12-step process is admitting you have a problem. I have not yet dived into to Kubernetes. It would increase the complexity and cost. So, when you need it, you need it. We did not need it. So, and we could always add it later. We could still add it under Fargate. It can be run under Fargate in AWS. So Fargate is sort of hypervisor isolation. Kubernetes alone only has kernel level isolation. And I'm sure Chris can explain in much more detail what that means. But it basically has to do with better level of security.
You are not wrong. You're right on the money.
Awesome. So Kubernetes was overkill for us for this particular case. So that's why we didn't go to Kubernetes. And we'll be making these slides available, right, Jim?
Yep. We can drop them into Slack for everybody.
Yeah, awesome. So the web, why did we move to full-on React and everything? So Preact wasn't compatible with certain libraries. Preact is sort of a cut-down version of React that's actually faster. It's a little bit better performance, or at least it's better performance without a lot of tuning. It's sort of pre-tuned. You can tune your React, full React, to get really good performance, but it takes some magic. In Redux, we needed sophisticated state management because we wanted a GUI. We didn't want somebody to be sitting there with your AWS CLI and typing in stuff. We want to just give it to somebody, have a nice friendly GUI and say, oh, I want this, I want a training class next Tuesday. We're going to have 30 people in it. Here's the emails of everybody, and just to be able to do that from a GUI. So to do that, we needed, TypeScript and everything. And WebSockets is an interesting one. We introduced that about halfway through development. And what we realized is we were polling a lot because we wanted to see the health, right? We wanted to make sure that as we were looking at all the instances, if any one of them goes down, we needed to see that immediately. So we were constantly polling. And what we found is using WebSockets was way better and gave us better performance. So we did that. Much more user-friendly, supported non-technical users, and no more security through obscurity. We had proper authentication authorization. So there's major benefits on the GUI. That was a slam dunk. All right, next, backend. Why did we change the backend? So we went to Go. Now only Python, Go, and Java have native support in AWS. The other ones you can do, but it's a little bit more work. And the Go has a really good startup time and better reliability. It turns out that statement is a little bit controversial. I think they've done some funny things to make Java really fast to start up. But in any event, it's certainly one of the fastest, if not the fastest. And DynamoDB, we had to store metadata, CloudWatch for monitoring. Of course, we could do better with New Relic. Now I know that. But we use CloudWatch as sort of at least get something out there. So the instances started up a lot faster. The trainer could see the list of the students. They could see the ranks and the titles. Very important to know who's the captain, and who's the civilian. Very important. So we could monitor the instance health, take attendance, all that stuff. So we got really rich functionality now. So now let's talk about moving to serverless, and the Lambdas. So why did we do this? Well, Fargate, what does it do? Well, it auto manages and provisions the instances for us. So and it gives you the metrics via CloudWatch, and it's pay as you go. So Fargate is this really nice coordinator that we used. It's an AWS thing. The step functions, very interesting. So the step function, I'll have an example what I want to get to soon. I'll show you. But basically, you're taking your workflow and you're bringing it outside of the application. So instead of having your in your app say, do this, then do this, then do this, then do this, you basically have your lambdas do one thing and they kick each other off. Oh, now it's time to do this. Now it's time to do that. So you're literally deconstructing your server app into tiny little pieces. It's really, really interesting. Very different way of doing business. Very different way of developing. And so the lambdas become just very, very low overhead. So the benefit is pay as you go only when services are active, servers. So basically they start, they stop. So it is perfect for our training, right? Because our training is just, a couple of hours and then we're done. So that was, trainers can schedule a class far in advance with confidence that the instances will be there when needed. So literally you would say, I want a class next Tuesday, and you'd have the step function say, when it comes next Tuesday, fire me up. Very interesting. You could literally schedule these things. So it's really interesting stuff. It reminds me of sort of batch jobs in the old days. And for automatic delete. So I no longer had to remember to fire stuff up. I no longer had to remember to kill stuff off. It just did that for me. So it's just a huge win for usability. So what about moving to Terraform? Why did we do that? So Terraform, maybe some of you are familiar with it. Basically, you can say, oh, I want this VM and I want this, a different security group, and I want to have these different instances and connect them, and I'm going to configure the firewall rules and all this stuff. So you can do all of that in a script instead of, by clicking. So that's great, but SAM takes it up a whole nother level. So instead of these really low level instance by instance configurations, with SAM, you have a higher level of abstraction. So it's a big win. I wonder if the only problem is it's AWS specific. The thing I loved about Terraform is it works on every cloud, and it even works on VMware. So it even works on-prem. So I'm hoping that either Terraform will come up with something like that at a higher level, or some other tool will arise. But for now, the pendulum has swung. The pendulum goes back and forth all the time, right? So it is swung away from open source, and now the vendor solution, in my opinion, is the better way to go. So no need to purchase or support Terraform. And kind of here's what it looks like. So you can see this is a SAM. I know that's hard to read. I apologize, but basically it's like YAML. So you basically have your definitions, your properties, and so you just define some things and everything starts up. So you're not writing code, you're just doing all this stuff in SAM. So why did we go to GitHub Actions? Much simpler. The YAML is so simple and easy to read, at least for me. And I've been using Jenkins for 10 years, so I know all about it. I know Jenkins, Blue Ocean. I've tried all the plugins, or a lot of plugins anyway. And I think, to me, YAML is a huge win. And not only that, they're opening it up for third-party actions. So there's new kinds of actions you just plug in all the time. So I think this is a big win. I think this is the way the industry is heading. So if you haven't looked at GitHub Actions yet, I highly recommend you do so. It may not be the right answer for every project. GitHub issues. They have GitHub has issues. So it's simpler. It's definitely not really comparable to Jira, but for a tiny little project like this with 3 people and like 2 months, it was completely fine. It was good enough. And then the GitHub wiki, it's not Confluence, not by a long shot, but it was good enough for us for this tiny little project. So for us, putting everything in one place was a huge win. So we didn't have to set up an environment, lower learning curve, no extra licensing costs, everything's in one place, everything right there. So I know Microsoft purchased GitHub. I don't know how you guys feel about that, but to me, I still love it. I have, so anyway, this is the architecture. So you can see that I won't spend a whole bunch of time here. I'm almost done. I know we're running out of time, but so you can see that you'd come in to the authentication, and then what would happen is, I'll go here. So you see this Lambda REST function. Here's a step function to start a class, and here's a step function to stop the class. So this would get kicked off at a certain point, and then it would say, oh, okay, invoke this Lambda to actually start the class. Invoke this Lambda to actually stop the class. And then Fargate would do that by firing up Docker images in the containers. So it's kind of a, it's very, it's a very different style of architecture, right? It's like, as far as you can get, it's really, you could see where this could get way too complex if you had a very, very big application with hundreds of functionalities. You'd have to really think twice. Do I really want this level of complexity for a large, complex thing? But for us, we just had a couple of simple things. It was a perfect match for us. So, but it's very much taking that microservices concept and turning the dials up to 11. So I'll pause here just for 1 second. I'm nearly done. Any questions on this this picture here?
Again, feel free to take yourself off of mute if you want to ask anything or drop it into the chat. Pause for just a second.
So GitHub Actions is like CI/CD pipeline stuff, right? Just to kind of clarify.
Yes, sir.
So at our org, we're using Azure DevOps.
Oh.
And I think I'd be like, for an equivalence there, it would be like Azure DevOps pipelines, I think. And it's kind of like logic. That's what you're using it for, like logic where it's like if the branch is updated, do this kind of stuff, right? Just to understand that better.
Yes, exactly. And in fact, I can show what I can do is share my entire screen. Hopefully you can see. Is that coming through?
Yeah.
Okay. So here's the GitHub. And if we go into the code, into the action, hey, let's check it out. There it is. There it is, GitHub action. So you can see that. So it's getting a start time, doing the SAM validate, run the Go tests, and set variables, do a SAM build. So a lot of this stuff is sort of underneath SAM commands, because SAM is doing everything for us. But there you go, npm install, npm test. There's your familiar stuff, npm run build. So you can see it's not that different from a Jenkins file, really. You could easily convert a Jenkins file into this, and vice versa. So, but that's your YAML based build.
Nice. Yeah, that makes sense. Cool. And somebody just asked in chat too, have you been able to drop Jenkins for CI/CD?
Certainly for this project and in other projects, yes. And that's because that's the thing. It's sort of like, well, if I was in one project recently where they used Kubernetes, and part of Kubernetes was we had a development environment in Kubernetes and then a production. And in development, they had to stand up Jenkins. And I don't know, whatever reason, but it was going down, it was problematic. And it was just like one more headache. With this, there is no headache. You drop in your YAML file, you're done. Nothing to install, nothing to monitor. It's just, GitHub, I have to say, GitHub just seems really, really solid. So, you pay for that, but to me, the trade-off is well worth it.
Yeah, cool. Thanks.
So that's that's what we came up with. And we're continuing to make little improvements. But basically, just to show real quick what creating a class looks like, you can see, here's the name of the class, the start and the stop. You can say launch immediately. Otherwise, it'll launch exactly 2 hours prior to the start date, and it'll automatically destroy 2 hours after the class ends. If you click this, you don't have to. You could, in some cases, you might want the instances to remain available, and that's fine. You don't have to click that. And we have a trainer, a co-trainer, and a support. Nowadays, we just need one trainer. One trainer can do everything. So we don't really need but sometimes if you're helping somebody to learn how to train the class, you could have a co-trainer. So we have that. So how does it work? So the SAM configuration file registers our state machine. And the state machine, remember, is like the class is registered. Oh, is it time to start the class? Yes, no. Is it time? Yes, it's now time. And then you do it. So this is, we just want to go through real quick an example. So the state machine specifies wait until the launch timestamp. So you see this launch timestamp $. It's a variable, but you can see that. So we're waiting before the launch. And then after this step is done, it's going to start the ECS the Elastic Container Service tasks, which are the Docker images. So it's basically a very simple state machine. And when it works, check this out. In AWS, it shows you a little graph. This is the step function monitor. It's part of AWS. If you're using step functions and lambdas in AWS, you'll have this. There you'll be able to go to this. And you can see the little state machine here. So it waited, and that succeeded. So it basically, so you can see that started October 20. So what this is saying is on October 26th, I created the class, but it didn't actually invoke the class until October 28th. So it was waiting until 2 hours prior to the start of the class. So my class happened on October 28th. So that's sort of what it looks like, at least some quick idea. And monitoring a class, here's the GUI we have. It's not perfect, but you can see the little instances over here. You can see who's attached to them, and you can see that they're green, they're active. And by the way, this little arrow here that's joined, that means automatically put this person on another instance. Find a blank instance. You see they've got 2 blank instances on the bottom. Automatically put somebody in one of those. And you do that if this active little thing turned yellow or red. And you just click that button, boom, they're on a new instance. Bob's your uncle, you're done. So, so he's basically, what we've done here is we've created a training provisioning server. So, so basically any training class that can be contained in a Docker image, we can provision this way to any number of users. So it's pretty cool. So the vision going forward, we're going to probably connect that to probably Moodle to do video on demand, and then Arlo. So Arlo is what you'd use for, like, if you're a training organization like us, you need to charge people money and you want them to sign up and do all that stuff with Eventbrite. Arlo takes care of all that stuff. So basically, by connecting our TIM, Training Image Manager, to an LMS and to a TMS, you get a full training solution that can do everything, basically everything like Udemy and all those other guys. So this is our vision going forward, because we're, becoming a training organization. So the only one we had to build was the one on the left. Maybe it might be you're right, but all the other guys were going to, just incorporate a COTS product. Haven't decided between Moodle and Blackboard yet. They're both good, but those are the options there. So the key takeaways is that we basically started here and we ended here. So will serverless technology work for me? Yes, if your work is bursty, you have workflow steps and coordination, you're free to re-architect logic into lambdas, you may not be, and you can use the best supported platforms. Is it going to optimize your use of, is it worthwhile? Yes. Because you get huge usability responsiveness gains, at least we did, significant performance or reliability improvements, and excellent tool and API support. So cost savings, you can see there's some cost savings there. So you don't pay for downtime. Servers is only running when you're actually needing, and we realized 45% savings, but your mileage may vary. And that's it. So.
All right, Craig. Thank you very, very much. I want to open it wide open now for questions. You can take yourselves off of mute. You can type your questions into the chat. Anything at all from anybody. Yeah, great topic. I'm sure there are a lot of stories out there, even with just the group here, of different things they had to do during the last couple of years to adapt. We certainly did, even on this side, right, with NADOG, but.
How long did it take you to You said you already started with containers and stuff. How long did it take to implement all that, and how big was your team?
Those are great questions. So actually, you can still see my screen, right?
Yeah.
So so let's see, I'm finding it here. Oh, here we go, milestones. So first milestone, MVP. So, and then version 1, support internal users. We wanted to have trainers that wouldn't have all administrative rights, but they'd be able to start instances. And then 2.0, and finally we're in 3.0 right now, and we're not done yet. But so you could see that it's been since February of this year.
Nice.
And so this itself took us, gosh, when did it take us? Closed on February. I think it was from like 4 months. So, but it was only 2 people. We literally had a skeleton crew.
Wow.
And we got it done in 4 months. Now, if we'd had a real team of like 6 people, we could have get it done in a month. So it was pretty fast. Surprisingly.
Yeah, seems good. Definitely seems good. Nice.
It would have taken you 12 because everybody's got a different idea.
Yeah.
Yeah.
Agreed.
It's almost easier with less people in a way.
Yeah.
Totally agree. So they see this, we're actually working with PMI now, and we're offering Jira classes through PMI New York City. And so there's some things I wanted for this class. Most of them are done, but you can see I'm still waiting for a couple. And what's interesting, I'll just show you real quick, is basically what I want is a method so that images are automatically added. What that means is that anytime I create a new Docker image and put that Docker image in a particular bucket under ECR, it'll automatically show up as a new option in the training image manager. So I can create new classes right away with no configuration, no YAML files, nothing, no SAM, just make it dynamic. So you just add a Docker image and boom, you've got a new class just like that. Nice. So I'm always like, it's this continuous improvement, right? So it's dangerous, right? Because I'm a software developer, so I can think of so many things I want. So like never be done.
But then you can just brain dump them to backlog items or whatever, right? And
yes, sir. Yeah. So it's not, yeah. So these are really, at this point, it's really the nice to haves, like, oh, let's make it so beautiful and perfect. And I had them do like update the documentation. There's a Golang Go something or other. So you can automatically publish the code level documentation. So it's, all the cutesy things for, so that 5 years from now, I won't curse myself. Right. So that's the main thing I'm doing now, just cutting down the number of times I curse myself 5 years from now.
So Craig, would you say that at this point you've got a process where you could take an organization that has a certain amount of agile maturity and the developers are maybe the programs teams are their sprints are in sync and the teams are checking in their code on a regular basis and doing the basics well, and you can overlay a kind of more sophisticated DevOps CI/CD infrastructure on top or set of processes on top of that. That's kind of what I'm reading this as going from good, strong, basic agile to a form of DevOps maturity.
Exactly correct. Yes, sir. That's exactly that's what we do.
Yeah,
perfectly.
I definitely want this. I definitely want this slide deck. All I want to show it to. This is great. Very nice demo. Thank you.
Make sure I'm going to drop the link to the NADOG Slack group again into the chat for everybody. So we'll put the slides there as soon as I get them from Craig. Cool. If I can figure out how to use the chat. There we go. Okay, cool. All right. Any other questions, comments, or anything for Craig? All right. If not, I am going to stop the recording here. Before I do, if you're watching on YouTube, sorry, you don't get to continue with us. Next time, join us live and you can continue the conversation here. But thanks for watching.